Okay, let's get started. So first off, I hope everybody is ready for that IE2 coming up at the end of the week. Okay, try your best for that one. Okay, try your best. Make sure you prepare this week. Review the old exam that I released, during the weekend or right before the weekend. It's really important that you score as high as possible on this one. Okay, because we're about to get started with module 3. Module 3 is going to have a few more concepts that are a little bit more sneaky. Right? So it's not only just about getting a good grade of IE2, which is always a good news. It's also about making sure that everything that's covered by IE2 is solid. The more solid you are on that material, the easier module 3 is going to feel. Okay? So make sure you make a good priority on that IE. Okay? Preparing for that IE. Okay, what do we have as a menu for today? So we have finally the dreaded module 3 now. It's not that bad actually, but it's actually the peak of difficulty in the past semester. It has turned out to be the peak of difficulty in this course, so I just wanted you to be warned about it. Okay, so we are going to talk about two things: inheritance and polymorphism. And polymorphism is a technique, a programming technique, that whether or not you like inheritance is actually quite useful. Okay, but it relies on inheritance. You cannot have polymorphism without inheritance, so we're going to introduce them in order. Inheritance first, polymorphism right after that. The main theme for this module, you're going to see that real quick, is that we are at a point in the course where we pretty much have established that code redundancy is evil. Okay, I've been repeating that as a mantra over and over. Code redundancy is something you need to eliminate. For example, constructor chaining. Okay, many of you are starting to get comfortable with the idea of chaining constructors one to the other. We are going to do that for constructors. We are going to do that for the toString method that we started using not too long ago. We are going to do that to just about anything, because this is a way for us to centralize in one location, kind of like what we were discussed before class, right? When you have a diagram here on the board of constructor chaining that we're discussing, the bottom constructor takes 2 parameters. That's a place where the work gets done. And it's not always that clean. Sometimes you have 2 or 3 constructors that are going to be doing the work in slightly different manners, okay? But you are trying to avoid repeating that stuff over and over all of your code, okay? Well, inheritance is going to help us do that, but just at another level. The same way that constructor chaining allowed us to kind of avoid duplicating code among constructors, the same way that if we chain different toString method with one another, you're going to see what I mean when we cover inheritance, is going to help us avoid code redundancy. Well, we can do that at the level of an entire class. And that's exactly what inheritance is going to do for us. So the module has a few conceptual, I would say it's mostly conceptual because the syntax is easy, okay? But it introduces brand new notions from object-oriented programming principles, right? So we are going to talk a lot about inheritance. This is going to be our first blurb here. Then we're going to talk about the toString method, because the toString method is kind of a poster child to show you what you can do with inheritance. You never had to worry about displaying an object on the screen, okay? Before I told you, hey, if you change the toString method, if you write a toString method in your class, then you're going to be able to display it in a more readable manner, okay? Well, that means that before you did that, there was already a toString method somewhere hanging around. The one that just made the object appear as, the name of the class, at, and then the name of a reference, right? Well, where does it come from? Inheritance. So we have been technically using inheritance since day one. It's one of those many things that in Java, when you learn to program with Java, you are using actually a lot of OOP stuff without knowing it. So progressively, we are uncovering all the layers. So toString is really good for that. After that, we're going to talk about polymorphism, so there's no point in me talking more about it. But the same way that we illustrated inheritance with toString, we are going to illustrate polymorphism with the equals method. So you heard of the equal methods in the context of strings. I told you when you want to compare two strings, you should use dot equals or dot compare to, okay? One of the two methods, whichever you prefer. Well, the dot equals method is much more general than that. It's actually almost everywhere, okay? It's almost everywhere throughout the JDK, and it allows you to compare two objects. So if you ever wondered how am I going to ever compare, for example, a student object to another student object or something like that, well, you would have to provide an equals method in your class student in this case, okay? The same way that you have to provide a toString method if you want the object to be rendered in text in a human readable fashion, okay? So again, that means that there is a dot equals method by default. And that method, we get it in our class without having to do anything, just because of, again, inheritance. Okay. And then the textbook introduces array list towards the end of the chapter. So we are going to flip it over. The first thing I'm going to do today is introduce the concept of array list. Then we move to inheritance. Then we move to polymorphism. The concept of array list is easy. How many of you use Python in COP2513? Wow, you're the only one. Usually it's more than that. Okay, so you are going to see that now we can do kind of the same stuff that Python was doing in terms of ease of use. Okay, arrays. I made it a point to finish our last examples with 3 different code examples, live coding and exercise, that were resizing arrays. It's a good thing for you to know, especially for COP2513 coming up. Okay. However, in practice, I don't want to have to do that. Okay, it's error prone. I want arrays that resize themselves. Well, the basic Java arrays, they're not that great. However, array lists are a class. Array list is a class, sorry. Array list is a class, and array lists are actually objects that behave like arrays, but that have all sort of nice features like automatic resizing, etc. So we are going to start with that because it's kind of independent. I can start with array list, without having already prepared the ground with inheritance and polymorphism. It's easier than inheritance and polymorphism, so it's a nice, gentle introduction. And third reason, once you start using array list, you probably are not going to go back to basic Java array, except if you absolutely have to. And I will point out the situations, the scenarios where, array list kind of fall short and you might want to do something else. But there are very few of them. So from now on in the course, every time we are trying to store a sequence of element or like a pool of element or whatever, we are going to use that data structure that is already there, ready for us to use the array list. Okay? So as usual, reading assignment, again, it's not optional, chapter 11. So be careful, like right now we are going to start by the end of the chapter. So if you want to read, and I really encourage you to read, after each lecture a little bit. If you want to read tonight or this afternoon, make sure that you go to the end of the chapter where the array lists are. We are going to have a PQ that is already released. I don't think I have set the date yet for the graded quiz. I'm going to do that shortly. We have some practice exercise, so let me explain a few things about the practice exercise. We have pretty much, let me grab the laser pointer here. We have pretty much one. So the first 3 exercise are one group. Then those 2 guys are a second group of exercise. And then finally the 3 last exercise are a third group. Okay. At the end of this session, once we are done introducing array list, you should be able to jump right in and do the first 3 exercises. And I really recommend you do so very, very quickly. Okay, like today, tomorrow, at least try to do one of them. If we have enough time today, I will start doing the to-do list as live coding, just to get you started. And then once you understand how to-do list is working, doing the same thing with invoice and course is going to be relatively easy. Okay, so what are you going to do in those exercises? You are going to rewrite those classes that we already wrote. So repeating, right? Repeating always the stuff so that you get very good at it. And then you are going to rewrite those classes, modify them, and you are going to do something that I called here composing with array list. What does that mean, composing? That just means that that's what we have been doing with those 3 classes, to-do list, course, invoice. That means that you have an array inside, and that array is a list of references to other objects of another class. Okay, so we would say, for example, that the to-do list class is composing the to-do item class. Okay, it contains to-do items. Okay, so we've done that with an array. I just want you to replace the array by an array list. These are very simple exercises. You see it done one time, you should be able to go home, like in maybe half an hour maximum, get rid of the 2 over exercise. Okay, do it so that after that you've got enough practice that you're ready to use array list everywhere. So we're not even going to have to worry about, arrays, resizing and stuff like that. You are just going to be ready to use array list for what it's good at. Okay. The next 2 exercises, once we introduce inheritance, these are going to be your go-to exercise. Okay. So just basic application of inheritance. So maybe by next module, we should be done introducing the concept of inheritance. You can already tackle those. And then the last 3, no, they are not on polymorphism. It's hard to find very good exercise on polymorphism, okay? But those are actually also on inheritance, but they are going to tie it together with array list. So we are going to see that we can compose with array list, which is what we've done until now. For example, composition is the association we have been using the most often, but we can also inherit from array list. So what does it mean? We'll clarify that, next lecture and the one after that, but that's going to be pretty much the end of our practice exercise here. And that gives you an idea of what to expect also for the next IE at the end of this module. Okay, so this module is going to be a little longer, so expect maybe 2-3 weeks between now and the GQs or something like that, 3 to 4 between now and the IE. Okay, I'll keep you updated, but this is pretty much a roadmap to progress your skill up to the next milestone, the next IE. All right, and that's it. That's the overview of the module. So, as I mentioned, we are going to not follow the order of the textbook. We are going to do a quick side here with array list. So, what are array lists? Well, first, why do we need array lists? So, it's because arrays are wonky. Arrays are really awkward to use. And when I mean arrays, I mean basic Java arrays. So, let me start by making a point-by-point, comparison between basic Java array and array list so that you can see the strengths and weaknesses of both, okay? So what you can store in basic Java arrays, we've done it already. We've stored primitive data types. That was COP2513 at the beginning of this course. And we've stored also reference data types, okay? So we have, for example, an array of to-do items. Okay, so we can store anything we want pretty much in regular Java arrays. What about array list? So that's maybe the one weakness of the array list, is that you can store only reference data type. You cannot make an array list of int. You cannot make an array list of long, of float, of boolean. You have to go with the wrapper class if you have such primitive data types, or you make an array list of student object, scanner object, circle object, whatever class you define. So it's always an array list of a class. A custom class, a class from the JDK, or a wrapper class if you really need an array list of int, okay? But never a primitive data type. And that by itself is the illustration of what I was talking about last time, okay? In the last 2 lectures, I've been saying, we really need those wrapper classes because there are so many great things to use, ready to use in the JDK, and we cannot use them on the primitive data types. That's an example, okay? If I want flexible arrays, I need to have all of my elements treated as object. What about the size? So the size I already mentioned. The problem with basic Java array is that when you create the array, when you do that new, int square bracket 5, that's it. You signed up for an array of size 5. Were we ever able to expand the size of the array? Well, technically you could say yes. You could say, you've done that for the last 3 live coding sessions or something like that. True, but I didn't expand the actual array. What I did instead is I created a new array that was larger. I copied everything by hand, and then I directly replaced the old array by the new array. I literally took the attribute that was referencing my data, and I said, now you reference that new array instead of the old array. So it's a little wonky, like I said. It's a little awkward, it's error prone, and it's slow. Okay? So for array list, that's where it shines. The array list, we are going to have a method to add element at the end of the list. Okay? And however that method works, I don't care. So whatever policy it uses to underneath, store the element in an array and maybe resize that array dynamically, and maybe it's using a resizing size that has been, statistically proven to be like most efficient or whatever. I don't know what's going on there. I don't care. All I know is that I call the add method every time I want to add a new object at the end of my array. And then the implementation will make sure that I have always enough room. That's it. Okay? And the same thing is going to go on for removal and insertion operation. I think it was an insertion operation or removal, I don't remember. I left one of those two operations as an exercise. I don't know how many of you actually completed that exercise. I didn't hear much about it in office hours, so I'm assuming it was not super popular. But those of you who tried actually to complete that exercise, that part that I left as an exercise, that was actually very good practice. Okay? Either that should have been like easy like that if you were already at A level. If not, if you were missing anything that would have helped you, catch up on what you are missing. So those operations, removing one element from an array, adding one element from an array, they are not completely trivial. Why? Well, think about it. In the case of basic Java arrays, right? If I want to add an element at the end, that's what we have been doing in all of our live coding. That's relatively easy. Okay, I find the end of the array, and I add my element. The first empty slot. Okay, that's fine. That's fine as long as I have room in the array. Otherwise, see the remark that I had before about resizing. What about if I want to add an element at the beginning of my array? So that would be index 0, right? So I try to add an element at index 0. What happens? I cannot just overwrite what is at index 0. I'm going to lose it. So what I need to do is I need to put what is at index 0 at index 1 to make some room, then insert my element at the front of the array. But to move from index 0 to index 1, the data that was there, I need to also make room at index 1, so I move first the data at index 1 to index 2. To do that, I need to first move the data at index 2 to index 3, so I need to shift all of my elements one space to the right in the array just to free that first slot, and then I can insert. So when you guys discuss in data structure about algorithmic complexity, you are going to see that this operation is what we call a linear operation. And we have this notation, big O parentheses n. That means that the order of complexity of this operation is directly linear, directly proportional to the number of elements you have. What that means is that if it takes you a microsecond, to move one element from one cell of an array to another, well, if you have 10 elements in your array, it's going to take you 10 times that microsecond. If you have 100, 100 times. If you have 1,000, 1,000,000 times. It's always directly proportional. So the more elements you have, of course, the longer it takes you to actually move data. So do you care about doing that in a little exercise that we write together where we have 3 to-do items, in a to-do list? No, you're not going to feel the difference. If you start manipulating large amount of data in an array, then yes, you're going to start to feel the burn, okay? You're going to feel the pain of having to move all of those elements like that. So again, instead of doing it by hand, instead of making it error prone, instead of maybe having an implementation that is, functional but not so great, not so optimal, we are going to delegate that to array list. And array list has a method that allows you to remove and add elements. One for removal, one for addition, okay? And those methods allow you as well to specify where you want to remove things. At the end, at the beginning, or even in the middle. Okay, after all, I took the two extreme situation, but the middle situation is the same. You just copy everything that was before, add the element, and copy everything that was after, shift it to the right by one location, by one place. Okay? So, all of that, we're not going to have to do it. That's why we use ArrayList. What does the ArrayList class look like? So here's a UML diagram. So the first thing that's weird about this UML diagram, so at least not all of the method, but most of the method, actually all the method we're going to use in this class, that belong to the class ArrayList. Okay. The first thing that's weird is right there. There is a remove method. So you would have an object of class ArrayList, like myData, and you say myData.remove, and now you give me a reference to an object that is already inside that list, and you want it to be removed. So please note, first thing, okay, an array list, just like a regular array in Java when it contains, objects, contains references. So removing an object from an array list, just like removing an object from a regular array, doesn't mean that you destroyed that object. Okay? It just means you have your array list somewhere in memory. There's one reference to that object here. And what you do is you say, I don't want to reference that object anymore from within the array list. Right? So you remove that reference here, you're done. So the array list no longer refer to that element. This element doesn't belong anymore to the array list, but the element is very much still alive in memory. Maybe it's being used by other parts of your code. Maybe you have other references to it, right? Only when all the references to it are dead, then the garbage collector is going to come and, rip it. But the bottom line is, we pass here a reference to an object. So if I have, for example, a student object, a specific student object like John Smith, is a student object in my array list of students, well, then I'm going to have to pass the reference to that John Smith object. So same reference, same object, right? So that we're going to have to try to do a little better than that, okay? That's not always what we want to do. Sometimes we want to remove based on the index. So we want to say, for example, remove the first element. So we would use this over remove method here. And sometimes you want to say, for example, if you have an array of to-do item, sometimes you want to say remove the to-do item from the list that has, for example, a title that says wash the dishes. Okay, so that is not covered by array list. Array list allows you to specify by its reference which object you want to remove from the list. It allows you to specify by its position in the list, its index, which object you want to remove. But if you want to do anything else, you're going to have to write some code. Why? Because Java doesn't know how to compare, like a to-do item object to another to-do item. It's a class. So it could be structured however we want. It could be having whatever rules for comparison we want. So bottom line is, when it doesn't know how to compare like that, it just offers you the basic options, remove by index, remove by reference, and that's it. There is another thing that's weird here. Does remove method, and both of them actually, they return a Boolean. The meaning of that Boolean is true, the removal happened. False, the removal didn't happen. And that might feel a little wonky. I'm not bringing it up because we're going to use that a lot in this class, okay? But I want to bring it up because every semester I have a few students that bring up the question at some point in their study, and they say, I've been thinking about this method and it doesn't make sense. Why does it return a Boolean? After all, when we insert something in a list, in an array list, right, we don't necessarily have a Boolean being returned. So what's happening? Do we need to return a Boolean for every method, just for the method to tell you, yeah, I did my job? No, we've never done that before, okay? So here, this is a little special. It has to do mostly with issue when you do concurrent programming. So concurrent programming, we're not going to touch that with a 10-foot pole in this class, okay? But you might touch it at some point in your curriculum, depending on if you take some elective that go toward, operating system and that kind of stuff. Concurrent programming is when you have think of it this way, several part of your code, several methods that are running in parallel. So for example, each method is running on a thread of your CPU, and it's still the same code, it's still the same app, but you are executing two methods in parallel, and they share access to common objects, to common memory. They share the same memory pretty much, right? So when you are in a situation like that, if you have an array list that is actually shared by multiple ones of those threads, then concurrent access, meaning simultaneous access to the same array list by different threads that execute in parallel on different cores or different threads on the CPU, that can be problematic, okay? This makes actually programming a lot harder than what we are doing here in COP2512 and COP2513. So you'll have time to get into that later, but the bottom line is that under those circumstances, yes, sometimes you try to remove something and somebody kind of like cut you to it, okay? Somebody meaning another thread removes the item while you were in the process of removing the item, or you thought you were in the process of removing the item. So we are trying to detect those kind of situations. Another potential use of this is that sometimes you just use remove as a way to test if an item is in the list, and if it is, remove it. So in that case, the Boolean, it allows you to do two things in one shot. You test if the list contains the item, and if it doesn't, you know that it didn't have the item. If it does, you know it did have the item, but then you remove it immediately. Okay? So it depends on what you are trying to do. But again, for us, I'm mentioning that in passing so that you don't wonder about it, but for us, it's going to be trivial. 99% of the time, we're just going to ignore the return value from the remove method. But there is a point for them returning a Boolean. Let's take a look at the rest of this UML diagram for the class ArrayList. There's a lot of stuff that's weird, but it's always the same type of weirdness. So there is one weirdness we are going to have to uncover, okay, which is what the hell is E, uppercase E. So even in the name of the class, the name of the class is, so the full name is java.util.ArrayList, okay? So ArrayList for short. That means that when we want to use ArrayList, we're going to have to import java.util.ArrayList, okay? First little side remark. And second remark, the name of the class itself has, for the first time, lesser than, greater than, brackets, angular brackets, okay? And these surround a letter, an uppercase letter, E. So this E represents any possible type. So when you say, I have an array list, you really don't say just that. You don't tell me, I have an array list here. I don't know what you have in your so-called array list, right? So if you tell me I have an array list, you need to always specify an array list of, and then you tell me the data type of your element. So just like arrays, array list can only have one data type inside of them. So it's your whole array is made of, for example, integer or student or something like that. Okay, you cannot have mix and match. Yeah?
Yeah, so E would represent that data type?
E represents that data type, exactly. Okay? So the way that you read that notation with the angular brackets, you say it's an array list of E. So saying this class is an array list of E, it's like saying, hey, I have a function in math, f of x. So this is just declaring the class. It's just telling you, this is a class, it's named ArrayList, and it's going to be an array list of E, meaning whatever you are going to specify to me. Okay? So it's kind of like a formal parameter. Yeah?
So do we have to import it like that with the
So good question. Do we have to import it with the angular brackets? No. When you import it, you say, I want to be able to use the name ArrayList. So you would say import java.util.ArrayList, semicolon. Okay? And then anytime you want to create or declare an array list, then you have to say, hey, I want an array list of integer. I want an array list of to-do item, and so on and so forth. Okay? Very good question. All right. So now if we agree that this is kind of like saying, I have a function f of x, and then you tell me what you do with x. If you say I have a class array list of E, then in the code for the class and in all the methods, headers and stuff like that, you can use that E. That just means that right now I'm talking very abstract, okay? I'm saying if somebody was to have an array list of, say, a data type E, then I would have an add method, and that add method would take a parameter O of data type, whatever E is, okay? And then I would continue like that. Then I would have another method add that allows me to add an element at a specified index, and the element would be specified to me by, again, a parameter of type E. So I'm being very fuzzy here. This is called a generic class, and that kind of makes sense. It's a class that is generic enough to be able to work with many different data types. Okay, so you can have an array of this, an array of that, an array of that. That doesn't matter. The algorithms that we're going to implement, the way that the array list works, is still the same. Okay, no matter what you put in your array list. That's what generic classes are good at. So you can see that we have a bunch of methods here. We have clear that's going to say pretty much remove all elements from the array list. Contains that is going to test if a certain object specified by its reference is in the array list. get that returns to me a reference to E, whatever E is, okay, a reference to an object of type E, that allows me to get the element at an index specified as parameter. So I don't have the square bracket notation in an array list. I cannot say, hey, get me my data square bracket of 3. I'll have to write something like my data.get parentheses index 3. Okay? So the notation is not as natural as regular array, but you're going to see that we gain so much in the trade-off that it's not even a problem. We can get the index of a specific object. We can test if the array list is empty. We can, in case an object appears multiple times in the array list, we can get the last index, the index of the last occurrence of that object in the array list. We can remove, we talked about that already. I can get the size of the array list. Please note that there's nothing here to give me the capacity. Why? Because we don't care. The capacity is totally the problem of whoever wrote the array list, okay? As far as I'm concerned, as long as I can add elements, remove elements, etc., however you cooked that class, however you made it happen, is your problem. I don't want to even hear about it, okay? Capacity would be one of those implementation details. Remove again, and then set, that allows you to set a specific reference at a specific index to a value that is passed as parameter. So we have been using that letter E that represents whatever type of element we are going to put in our array list everywhere throughout the code. That's what a generic class does. So this is our first encounter with a generic class, first encounter with a generic type, okay? A little bit of jargon here, but very, very light. You are going to say that when you talk about an array list of E, then E is the equivalent of your formal parameters for method, okay? It's called actually a generic type. So this is something that you are going to have to specify when you actually want to create a very precise, array list, a very specific array list. When you do that, when you actually create the array list or declare a variable to point to a certain type of array list, then you need to give me a value for E. That's the equivalent of your arguments. When you call a method, you give me arguments. You give me value for the parameters, right? Well, here we call that a concrete type. So you have the generic type, which is when you write the class, you say E, whatever E is. And then you have the concrete type, which is, okay, I need a list of student. So new array list, angular bracket student, that's it. I set the generic type to a concrete value. Okay? So here's the syntax. The syntax is not too bad. Here's the syntax to declare first a variable, a reference variable cities meant to contain a reference to an object of class array list of string. So this is how you read it, with the angular bracket, array list of string. So that's how you declare a reference variable. That's how you would declare an attribute. That's how you would declare a parameter of type, array list of string. And this is how you create an actual array list of string. New array list. The parentheses here always, okay, this is like calling the constructor. But the difference is that between the name of the class and the parentheses for the constructor, you have this angular bracket again, these angular brackets, and they say that you want an array list of string. So if I declare an array list of string, then what I'm going to create and assign to that variable is an array list of string. You cannot say I want an array list of string and then try to assign to it an array list of integer. Okay, it doesn't match like that. So it's so straightforward for Java. It's such a basic concept for Java that Java allows you to kind of, alleviate a little bit the notation. So you see that here we specify, I want an array list of string, cities equal new array list of string. Well, if I don't put anything between the angular brackets here, then Java is going to fill in the blank for me. Okay? Java is going to be capable to say, given the context, you tell me you're trying to create a new array list. Array list is a generic class. It needs a generic type to be specified. Where do I find this information? Well, since you assign the result of this creation, to cities, and cities is of type array list of string, okay, I get it. You want an array list of string. And that's it. So this is called type inference. Think about inference as deduction. Java is doing some deduction on your code, some logical deduction to figure out what is the data type that you actually need. All right, so that's it. That's how we declare an array list. That's how we create an array list. And then from there on, the only thing that I need to tell you to watch out for is, again, to remember that when you create an array in Java, if you create an array of, let's say, 10 to-do items, you didn't create a single to-do item yet. Okay, that's the difference between primitive data types and reference data type. If you create an array of 10 int primitive data type, yes, your array object has 10 integer variable inside of it. If you create an array of 10 to-do item, your array has 10 references slots. So the potential to reference up to 10 to-do items. But until you create the to-do item object and put the reference in each of the slots, you have nothing in your array. You have null. Null for the first reference, null for the second, and so on and so forth. So I just want to remind you that the same is true here for array list. Okay? Once I create my array list of string, this way or that way, I don't have any string object on the horizon. All I have is now an array list object that contains a certain number of slots. I don't know how many because I don't care about the capacity. I let array list manage it for me, right? But it contains a certain number of slots that are going to each be of a reference data type and each able to hold a reference to a string. So later, I can point them to the right string or create a new string and put the reference in there. Okay, that's about the only thing that is kind of that has been a little tricky in the past for some students. Okay, so let's take a full example. Here's our import statement: import java.util.arraylist. So it's not a bad idea to have like a sort of default template, you know, like an empty file with an empty class and have just a list of imports that you use frequently. Well, add this one to the list. Okay. What else do we have? So we have a class test array list, we have a main method, and we use the syntax that we just learned, okay, including the type inference. We use the syntax that we just learned to create an array list and put its reference into the variable here, in this case, citylist. So citylist is going to be a list of strings, and now we can start adding stuff to that array list. To add to the array list, there are multiple add methods, okay? We are going to use the one that takes actually as parameter the reference to an object you want to add. So we have an array list of strings, so we're going to pass references to object of class string. In this case, I use the literal notation, so those strings are interned. Okay? Just make sure that you remember what that means. If not, come see me at the end of the class or ask question, okay? So citylist.add London. The London string object is created. Its reference is passed to the add method. The add method puts it in the first slot of the array list. And then citylist.add Denver. Well, add is going to add it to the next available slot, the second slot in the array list. So you can see here the array list is growing. I'm adding Paris, Miami, Seoul, Tokyo, and I have a list of cities inside the array list that is growing like that, and I don't have to worry about the size. Yeah?
Are you able to make multi-dimensional arrays?
Yes. You can have an array list of array list of array list of array list of array list. Okay, if you see that kind of code, probably, you know, probably it's bad code. Okay, it's just a little too complex for most application. But bottom line, yeah, theoretically it's possible. It's possible because an array list is literally a list of references. Reference to what? To one object, or to like an object that contains, you know, itself, you know, 50 million objects. There's no end to that. Okay, this is why those memory diagrams are like real lifesavers. When you are dealing with a data structure that goes beyond a simple array list, then having like those diagrams that show, you know, exactly the boxes with all the reference pointing to objects, etc. This is what is going to help you to really understand how a data structure is actually ticking. All right, some other basic operation on the list. I want to know how many elements I put in the list. Name of the reference variable to the array list dot size, basic, okay. I want to check if the list contains Miami. And this is where the textbook is a little bit deceptive, okay? They don't do it on purpose. Their goal is not to mess with you. But you're going to see. Let me explain. When I say citylist.contains Miami, I could read that and say, oh yeah, that contains method is going to check if my city list, array list contains actually the city of Miami. And it's not completely incorrect. But I want you to understand that really what we are saying here is I call the contains method. And I give a reference to the contain method, the reference to an object. And by default, what it's going to do is going to compare that reference to the reference of all the objects inside my array list. So does that mean it's going to compare the references or the actual text, the letters Miami? Well, it's a complicated question. By default, it's just going to compare the reference, which is funny because here, since we use, interned strings, the reference to the Miami that I wrote on the last slide and the reference to the Miami literal that I wrote on this slide, they're the same. So if it compares the reference, it's going to say, yeah, I can find Miami, but only because it's interned, okay? The second level of understanding is how does it compare the object? Well, array list is going to call, for example, the object's dot equals method. We didn't write a dot equals method for string, but it's there. So cool. What does it do? It compares the text. Awesome. So at that second level of understanding, I would say, yes, it's going to compare the text and it's going to give me an answer. So like right now, it's kind of nebulous. Okay, it's working. There are different reasons for which it could be working. I'm not quite sure exactly what array list is doing inside, in its innards. And then what? And then suddenly I use one of my classes. And then I start using one of my class, and then you have to be careful. Okay, you have to be careful about how exactly array list is going to locate an element of your class. If it compares only the reference, that's one way. If it calls the equals method and you didn't write an equals method, then it's going to be the same as comparing the references. If you provide an equals method, then something else may happen. Okay, so we are going to look at that in other examples. But I'm just trying to hear, for the first time, I'm trying to put the spotlight on why does little details matter so much. Why did we talk about intern string? Why are we talking about, what does it mean to compare to string? Why can't we use equal operator? We are comparing the reference or we're comparing the text. All of those little things that we covered so far, when you want to use array list, you want to trust array list to do its job right. But you cannot do that until you actually understand how array list does its job. So that goes back to the principle of abstraction. Remember when I first introduced abstraction, I told you abstraction is, I think I said something like controlled ignorance. Well, yeah, that means you don't have to know exactly how your car is working. Okay, but maybe knowing a little bit about how the car is working is going to allow you to pull over, when you hear a clanking noise and not completely ruin your engine. Same thing with programming. You don't have to know exactly how array list is working, but these are the questions that you need to Google when you just learn to use a new tool. Okay, so whatever language, whatever tool, these are the right question to Google. How is array list actually doing its comparison? And we'll play with that live coding so that I can show you how you can figure it out even just by writing a little bit of code. Okay. What about index of? Same thing. I pass Denver, right? It's going to look through the list, give me the position, if any, of Denver in the list. And then is empty is going to tell me true, false, whether the list is empty. So in this case, it's not empty at all. And then, so these are like the basics, the most commonly used, method. 90% of the time, we're going to use what is on the previous slide or what is on the slide before. And then sometimes we want to add at a specific index. So the beauty of adding at a specific index, so this would be index 0, 1, 2. So you see that we added a specific string at a specific index. And all of that shifting to the right of all the elements that were there before has happened automatically. Okay? So that's one of the reasons for which we want to use that stuff. Remove Miami, same thing. We remove Miami automatically. The items that were after, there's not a blank in our array list. The whole has been filled by the item that we're following. And we can remove by index, so 1 would be Denver. I remove index 1, this is the resulting list. Again, everything has been pushed to the left to fill up that blank that was in the middle of the list. And then, of course, array list implements the toString method, but just about anything we're going to use from now on implements the toString method, or expects you to provide the code for it, when you use inheritance. So we're going to come back to that real quick. So that's it. These are like the basic operation on array list. Nothing that is conceptually difficult, okay? You just have to practice, get used to it. This is exactly why we have those practice exercise. This table summarizes pretty much the comparison side by side between array and array list, but this time from the perspective of how do I write the code to do this or to do that, okay? So it's not as vague as the first comparison table that we had. So creation of an array, this is how you do it with a basic Java array. This is how you do it with an array list. We covered that. Accessing an element at a specific array. So for the basic Java array, the syntax for accessing an element to read it and accessing an element to assign it a new value is the same. It's a square bracket. A square bracket index, you can read the value at that index. A square bracket index equals something, you change the value at that index. For the array list, well, we have a get and a set method. Okay, so get the value at a specific index, set the value at a sorry, I cannot say that anymore. I have to stop saying specific, at a specific index. So it's a little bit more awkward, it's a little bit more verbose, but that's the price to pay to be able to use a release, so we'll pay it gladly. The length and the size. So this is a source of mistake. Like, it's a very basic mistake, nothing to worry about, but it's annoying. How do you get the size of a string? str, for example, dot size parenthesis. You call the method size. How do you get the size of an array list? Same thing. So string, array list, and most of the container, when you want to know their size, you just call the method size, and that's it. And then there is the exception. What if you have a basic Java array? Well, you don't call size, you call length. And it's not even like a method, it's actually an attribute. So a.length, for example, that's it. That's the size of your array. Actually, is it the size or the capacity?
Size, capacity.
You're both right. It depends on what you're doing with your array. Okay? So that's the problem, is that when you call the length, and then maybe this is why they called it length, right? When you call the length of an array, when you try to check the length of an array, it's going to tell you how many slots are available. So if you filled all the slots, that's your size, okay? But if you have, for example, a series of 10 slots, and each of them may be a reference, to an object, so maybe the first 3 slots have reference, and then you have 7 slots that are set to null. So now, this is where you would tell me, the length is a capacity. Okay, because the length tells you how many potential objects you can reference from within the array. But then, I only use 3. If the array is full, then we don't need to distinguish capacity and size. Okay, so if I would have to pick one, I would probably go toward capacity, because this is a generic answer. It will work every time, even when I'm not at full capacity. But it's a little bit more confusing, okay? So just watch out for that. Adding a new element, so the code is not there anymore here. Adding an element, inserting a new element in the middle, removing an element at the by index, removing it by reference, removing all the elements. These are the use case, the scenario, where you don't want to have to do it by yourself, by hand, using regular Java array. So this is where you would use array list instead. And this is true to the point where you are going to see in the example that I have in the rest of the lecture, sometimes we have an array, and we need a basic array, for whatever reason, okay? We need a basic Java array. And somebody tells us, can you shuffle that array for me? Can you take all the reference in it, and change the order like that randomly? And I'm going to say, okay, let me convert my array, basic array, into an array list, so that I can call a method shuffle that already exists, that is written for me. It's going to shuffle the array list, and now let me convert my array list back into a regular array, and here you are, here's your new array that has been shuffled, okay? It's kind of funny because there's a lot of overhead. Converting to an array list, and then array list to array, calling the method shuffle. But for good or bad, this is actually the preferred way compared to, I'm going to write my own shuffle method. No. you write code, you're going to make mistakes. That's the assumption, okay? Not just you, everybody. So if we have already code that we can use that has been vetted for years by an entire community of people that have been like auditing it, etc., yes, we want to use that. Does it make our application a little bit more bloated? Maybe. Maybe we use a little bit more memory. Maybe we are going to trigger the garbage collector. Maybe it's not as efficient, performance-wise, time-wise, okay, speed of execution. But these, at least for desktop application, these are the price most programmers and product managers are willing to pay for the peace of mind of I'm using code that has been already tested so many times over the last 10 years that there's like a ridiculous chance that there's a problem with it, okay? So that doesn't necessarily hold true depending on where you are programming. If you are doing like game development, for example, these are like people that are a lot more serious about their CPU cycle. They want to shove as many frames they can per second. So this is no laughing matter there. If you are going to trigger potentially a garbage collector, think twice. Okay? If you are going to allocate objects, think twice because allocation is expensive. If you go back to Android uses Java. I think that everybody knows that, right? So Android uses a form of Java actually. At the beginning of Android, we didn't have exactly the kind of device that we have nowadays. So nowadays we can waste space. So for example, you can create an array list. If you go back even just 5 years, maybe 7, 8 years, something like that, the Java developers that were working on Android were told pretty much don't use array list. Use basic Java arrays because you are going to waste memory. We don't have that much memory on the device for you to waste. And when you create your array list, it's going to be heavier than creating a regular array. And it's going to be this overhead, just forget it. So that's why when we teach programming, we always teach both. We teach the high level, convenient way, and most of the time you can go safely with that. But you need to know that there are other ways to do things, because sometimes you are in tight constraints environment, you cannot afford to go, the easy road, so you have to actually implement things at a low level by yourself, okay? Trust me, you're going to have a taste of low level when you do the C language in COP2513. But that's good. All right, iterating on the list. How do I go over every element of the list? So I can go forward, I can go backward. Here in this example, I'm going backward. So I'm using a counter control loop, okay? And then very few things should be new here. The fact that I use .size, the fact that I use .get to access the element at index I. Everything else, I have a counter variable I. It starts at the length of my array -1, just like with regular array. Then I keep going while that I is greater or equal to 0, okay? And then I decrement I at the end of every iteration, and then I get the element, display it. So there's a call to toString here that is implicit, and then put a space after it and move on like that, okay? So I can still do it like this. I can use a good old-fashioned counter-controlled for loop, no problem, and I'm going to display everything that is in my array list. There are better ways to iterate over an array list. Think of it this way. When most of the time you iterate over every element of an array list in order, okay? Sure, sometimes you have to do some funky stuff. You have to start at index 0, then jump to index 2, then 4, then 6, and then if there is a specific value at any point in time, then instead of jumping 2 by 2, you jump 3 by 3. If you have a sort of algorithm like that, that's going to decide, how many spaces it jump forward, backward in the array based on the value it encounters every time, forget it. You are back to basic Java arrays. Okay, this is probably your best bet. I mean, you can still make it work with array lists, but at this point, you probably want full control of what's going on in your array. But what about the other scenario? What about the 80% of the time where all we want to do with an array is go and say, for every element in the array, I want to do this or I want to do that? Well, array lists, again, have a convenient notation to do that. It's called a for each loop. So let's take a look at what it looks like. So here, I'm creating a new array list of integer. Again, repeat of the big warning, you cannot have array list of primitive data types. So I can never have between those angular bracket, int, float, boolean, double, char, etc. Okay? So here I have to go to the wrapper class, integer. and I add the value 14, 7, 39, and 40, which are not integer. So what's happening here? You guys remember?
It's like that typecasting.
Yes. So it's kind of like typecasting for the class integer. It's auto-boxing. Okay? So everywhere, every time I have an int, for example, and the context tells me, hey, wait a minute, you're calling a method that expects an integer here. Okay? So now that I know I expect an integer and I have an int, Java is nice enough to do the auto-boxing for us. Put that int value inside an integer box for me, and I don't have to worry about it. Okay? So auto-boxing happens here. And then here comes the for loop. So the for loop, just for comparison's sake, okay? Here's the counter control one. So this one is the same one as the previous slide, but instead of going backward, it goes forward. So not that super interesting. I can do it exactly the same way with a while loop. I told you that while loop and for loop are very, very, very similar. So you have two versions here of how I would iterate over that list and display everything, every number that I put in it, based on what I learned so far about Java. Okay? And then this is where we add one more syntax. So it's still using the keyword for, but it's a different type of for loop. It's called a for each loop. Okay? So why is it called a for each loop? Because this is how you're going to read it out loud. Okay? When you read this out loud, you say for each integer's num inside the array list R list. So the column here is read like inside, and we declare a variable which is going to have for scope only that for each loop. So the variable num exists only inside the for each loop. Okay, I cannot use it afterward after the closing curly brace here. Okay, so what does this mean? That means exactly what it would mean in math. If I say for every x in the set 1, 2, 3, 4, 5. What does that mean? That means that first x is going to be 1, then x is going to be 2, then x is going to be 3, and I'm going to consider each of those cases. So in a for each loop, when I say for each num inside of array list, that means that as the first iteration, automatically the variable num is going to reference the first element of the array list. Second iteration, automatically the same variable num. I don't have to mess around with indexes anymore. I just access each element with a variable num. Num is going to point to the second object, then the third, and this is done automatically for me. Okay, so inside the list, when I want to do my work, when I want to display all of the values on the screen, I just do system.out.println num. So first iteration, I display the first element. Second iteration, the second element, and so on and so forth. Okay. What is the advantage of this? Well, the disadvantage first is that I cannot mess around with indexes. I cannot go, forward 2, then backward 3, etc. It's all automated. I go one by one by one by one by one this way. I cannot change the direction. But the positive is that I don't mess around with indexes. So that means that this array out of bound exception going one too far, after the end of the array, or maybe ended up computing the position of an element and ended up with a negative index and trying to use that. All of those things cannot happen anymore. We made it pretty much idiot proof. So that even when we are tired and we are not paying attention, we don't commit mistake on things that are as simple as I want to go over every element of an array in order. Yes?
Are we still unable to set values with array list in the for each loop?
So we can set value. We have a set method. Okay, so the question is, can we still set values in an array list? Yes, we can use the set method to set a value at a specific index. I would say you have to be a little careful, okay, when you use array list and when you're starting to iterate over the array list and modify it at the same time. I would say if you do that, then use the traditional counter control loop, okay. It's just that the way that are represented on this side, the two different ways that are higher level to iterate over the array list, they are really good for the simplest scenarios, where you go element by element and you do something on each element, display, compute, send it over the network, whatever, and that's it. If you start modifying, it's like walking on a bridge, and at the same time that you walk on the bridge, you're trying to replace, some planks of wood or whatever on your suspension bridge. So that can lead to some interesting little bugs. Okay. All right. It's a very good question too. So that's a tool we're going to use most often when we want to just go through the entire array list, without asking too many questions. And then this guy here, I just mentioned it because the textbook does, and it's a good thing for you to have that on your radar. We're not going to use it that much until the end of the semester, probably. Okay? It's called an iterator. It's yet another way to iterate. It's a higher level than a counter control loop. And at the same time, it allows you to do more things than a for each loop. So how does it work? So the iterator is an object. And the role of that object is to keep track of, I am currently iterating in that array list, and I am at this position. So if you have your array list in memory, imagine that the iterator is kind of a ribosome or whatever. It's maybe too much of a bio analogy there, but it's something that's going to stick onto your array list. And remember that you are at this position in front of this element of the array list. And then it can move. The iterator move forward, backward, and then you can ask the iterator, what element are you on? And it picks the element, returns it to you. Okay? It's kind of a simplified, like cartoonish way to look at it, but it works. So I create an iterator object. And the way I create it is I ask the array list, hey, give me an object that's able to iterate on you. So I call ArrayList.iterator that returns to me an iterator that I call iter. And then I have a few methods available. We're just going to see the basic ones, okay? Iter.asNext returns true or false. So remember, the iterator is going to be at the beginning of the list by default. And asNext means, is there something behind? Is there something next? So as long as this is true, that means I have more elements to consider. So I'm at the beginning of my list, okay? Is there a first element in my list? Yes or no? If it says yes, then system.out.println iter.next. Give me that next element. So imagine that the iterator is pointing before the beginning of the list by default, okay? Is there a next element? Yes, the first element. Well, okay, give me that next element. Next. And not only it gives me the next element, but it moves also the iterator, so that now the iterator is sitting on the first element of the list. The next time I call asNext, it's going to look ahead and say, well, yeah, there is a next element after me. All right, so give me that next element. So it's going to return to me the value of the next element and move also forward like that. It's complication for nothing right now, because we know how to do this with for each, okay? So just keep it in mind, keep it in the cell of your RAM there. When we want to do things that are more complicated, like go forward, backward, then iterators become your friend. All right? Yeah.
If you didn't want to start from the beginning of the array list, would you still use the array object?
Say that again, sorry?
If you didn't want to start by default at the beginning of the list, would you still use that?
Yes. You don't use that object because that object starts at the beginning of the list. But if you wanted to start or to reposition yourself at a different point in the list, you would use a method to do that. Okay. So the iterator class has a bunch of methods. Actually, we're really just looking at the top of the iceberg here. It has a bunch of methods that allow you to do that kind of move forward, move backward, reposition yourself at that index. Or I want to start by the end of the list instead of the front of the list. All of this is definitely possible. And that's why we have this option. Because with the for each loop, you have none of that. So think of the for each as, the Fisher Price, of iteration on array list. There's only two buttons to push, a big yellow and a big red button, and that's it. You cannot go wrong. Then if you want to do something a little bit more evolved, iterators, and if for some reason the iterators are not even cutting it and you really need to have full control about your array at a lower level, then you go with Java regular array. Okay? All right, cool. These utilities, I suggest, if you are like me, I suggest you bookmark this slide, because this is the number one thing I always forget from one semester to another semester. If I don't use it, I forget the syntax. So it's conversion from array list to array, and array to array list. And we're going to use that, like I said, we're going to use that fairly of fun because array lists are so much more practical than array. We don't want to miss out on being able to use them. So here's the syntax to memorize. Okay, here I'm creating a regular array of string. So I'm using the block initialization syntax with a curly brace. I'm using interned string literals here. And then I'm creating an array list of string named list. And I want this list to contain the reference to the same object than this array. So please note, I'm not copying the array. I'm not copying the object inside the array either. Okay, I have my array. It's like a 3 slots with 3 reference to string object. And now I'm going to have my array list object that has also 3 slots in it that are reference to string object. I'm just going to refer the same string object. So the two containers, the regular Java array and my array list, they are going to both have references to the first string object which says red, the second string object that says green, and the third that says blue. And there are only 3 string objects. No need to duplicate them. Okay? That's the default behavior, and that's the default behavior in a lot of language. As soon as you have references to object, a lot of the time when you have a data structure, the data structure just contains a ton of reference to different objects. And then you can remove those references, you can point to new objects, you can maybe have 2 data structures that have reference on the same object, you can share things like that. It makes things a lot more efficient in memory. Okay? We try to avoid copying stuff if we don't have to. The first syntax I didn't finish. The first syntax is to create actually an array list based on an array. I'm going to use a new keyword, new array list, the angular brackets again. And as argument, I'm going to pass an argument to the constructor. And I'm going to say this argument is arrays, the name of the class arrays, dot asList. And I pass to that method my regular Java array. It's convoluted. Granted, no problem. I'll grant you that this is convoluted. As a matter of fact, when you write arrays.asList of and the name of a Java basic array here, it already kind of returns to us an array list. So sometimes you are going to see people use only that part, and assign it to an array list. Okay. Well, it's not exactly a full array list. It's kind of a bastardized version of an array list. It doesn't have all the features. It cannot be necessarily modified, and so on and so forth. So pretty much what I'm giving you here is a recipe that is foolproof. If you call this and then pass it as an argument to constructor for a real array list, then what you have at the end is definitely a fully functional array list. No little small prints, to read, asterisks, and so on and so forth. It will work for everything we need to do. So memorize the syntax, okay, and use that one even if you Google, some other sample of code that use a different syntax. These can mislead you to have some pretty nasty bugs, so let's avoid them. And then how do we go from an array list to a regular Java array of object? Well, that's easier, actually. So here we are. I have here array 1, which is a regular Java array. I create it based on the size of my list. So I'm assuming that I have an array list named list, okay, the one, for example, that is declared right here. So I look at the size of my list, and I use that to create a regular Java array of that size. And then I say list.toArray. So I tell the array list, reference to by the variable list, to use the method toArray to to copy its references inside an array that I specify as parameter here. And it's going to do the copy of the references. Again, it's not copying the object, it's copying the reference. Everything that we did on that swap method, that's why I spent so much time at the beginning messing around with references, okay? Everything that we did with the swap method, if you already started forgetting about it, tonight, go and review it. Okay, go and review everything that we did on the swap method, because this is the same kind of stuff coming back here. What's happening? Am I making a copy of the object? How am I passing the object from one array list to an array? Exactly the same way that we pass parameter. We copy the references. So the objects are not copied, they are shared, so I can modify them from either data structure. We have some little bonuses here. So for example, Once you have an array list, so I'm using that super long syntax here to convert a regular array to an array list. So once I have an array list, I have a bunch of methods. Some of them come from a class called collections with an uppercase C, okay? So the class collections in Java is where we group actually a bunch of methods that work on all sorts of containers, like array list, linked list, priority queue, trees, etc. Okay, so methods that work on anything that is a standard class in the JDK that contains a lot of references, okay? So one of the things that I can find here is max and min. So if I want to find the max of a value inside of an array, I can call collection.max, except that I cannot pass to collection.max a regular Java array. I have to pass an array list. So this is why here I have a regular array with red, green, and blue, and then I convert it on the fly into an array list, pass that array list to collection.max, and the collection.max is going to return to us, what is the maximum value in that array. So it's going to return red, green, or blue. Please note that the definition of max is very vague. It works on dates, it works on numbers, it works on anything that's kind of comparable to one another, so including strings. So the max for a string is going to use the lexicographic order. It's like saying, if I have Alabama and zebra, what is the max of those two words? Zebra, because it starts with a Z that is at the end of the dictionary, right? So the max and the min, we don't have to worry anymore about writing those kind of methods. We are going to use them. But to use them, we need to be able to create array lists when we need them. What about shuffling? I use the example of shuffling. Well, shuffle is another one of those collection method. So once you have an array list, and here I do the same trick, okay? I have a basic array, I convert my array to an array list, then I shuffle the array list, then I display the array list, but if I wanted, I could convert the array list back into a regular array. Okay? So that kind of conversion back and forth, yes, the syntax is a little weird, it's long, it's awkward, but just bookmark it, memorize it, put it on an index card, whatever you have to do. But being able to convert back and forth like that can save you a lot of time coding, okay, where you don't have to reinvent the wheel every time. So we're going to finish up with just a one slide example, and then there's one more slide after that, but it's like 30 seconds. This is an example that is actually trying to, if I remember correctly, ask the user to enter some values, some numbers, and put those numbers in a list, but make sure that you keep only one of each number that is entered. So your list should be a list of the unique numbers that have been entered by the user. So it doesn't seem to have anything to do with array list. But what it's going to show is when you use array list, you can do that kind of stuff without writing a lot of code. Okay? So a good exercise for you, if you are not convinced about array list, for example, is to try to rewrite this piece of code using standard arrays in Java. Okay? And don't do it on your own, do it like together as a group, or like come to office hours, right? The point is not for you to spend hours on that, but just to get a feel of how much more work it is when you use a basic Java array. So what do we have here? We have an array list of integer named list. We create it here. We create a scanner. We tell the user enter a bunch of integers. The input ends when you enter 0. So here's my value that I'm going to use to read integers from the user. A do-while loop, nothing tricky here, okay? I keep going while the value is different than 0. Value is equal to input, the name of my scanner, dot next int. And then I say, if negation of list.contain value and value different than 0, so that's my sentinel value, right? 0 means I stop. I just use a contains method here. If the list doesn't contain the value, then add the value to the list. And that's it. Okay? And then after I'm done doing this, I'm going to end up getting out of that loop when value is 0, and I'm just going to display the list. And that works with integers, that works with double, that works with float, and I'm talking about the wrapper class here. That works also with student, that works with to-do item, that works with... So from now on, from now to the end of the class, we are going to try desperately to use every time we can classes that are in the JDK to do the job for us. We're going to start becoming the good kind of lazy. as much lazy as we can, right? There has to be somebody else who did the job already for me. I need to find it, use their code. To be able to interface with that code, we use the object-oriented programming principle that we have been learning together. All right? That's it. I'm going to wrap it up here. If you have questions, just hang around. I'll stop the recording, and there's also office hours tomorrow, don't forget.